All right, so we're back out in the shop today, and we're going to continue work on the sandblaster tumbler. So today we're going to lay out some lines and then use the Pexto finger brake to actually bend the plates. The capacity is actually a little bit lower than I'm going to be bending, but I think it will be fine. We'll take it easy, and if we have to, we'll do some score lines with a grinder to kind of lighten it up a little bit. So let's check out the tools we're going to be using. We're just going to use our combination square and some drawings and a Sharpie. That's about it. That's all we need. So here's our drawing. Just very simple drawing from Fusion 360. So our bend marks are 10.033 inches apart on this base plate here. So we need to find the center first, and I'm just going to move my scale up until it's at 12-inch wide, till it's at the 12-inch width here. So moving the scale up until the corners are even with the outside of this plate, because everything has angles on it. So we're just gonna take it up there, mark it at 6. We'll put our square head on. Run that line up. Actually, I want to move that off the edge there. We'll just run that line. That's our center line. Again, off the edge. Continue that line up. Hopefully that furnace that just kicked on isn't too loud. So we need to move over 5 inches and 15 thousandths, really, a 64th. It's really not that critical each way. We could use a set of dowel calipers, even though I just said it's not that critical. We'll go 16. Scratch mark there. Right. Yep, right there. And we will scratch that side. And let's finish those lines out from this side here. All right. That is that. Probably pretty hard to see, but you can see the lines there. So that's actually where we're going to bend it at. All right, we got the first one laid out. Time to lay out the next one. Same thing, only slightly different numbers. find the center first. That method worked pretty well. I'm just going to bring this down until the corners of the 12-inch scale are flush with the outside, and then we'll mark it at 6 inches. Put our square head on. Mark the center. And this one is 9.783 from bend line to bend line. Half of that is 4.891. Once again, this is a little bit crazy. But if you can be accurate, why not be accurate? Get a scratch mark there. Scratch mark there. We'll transfer this line up. Same thing over here. Let's get you relocated and try to bend it. All right. Let's hope this works. Probably asking a lot. But sometimes you don't know till you try. We gotta try something. There we are on the line. And let's go. Nope, didn't like that. Wasn't clamped tight enough, maybe. I think that's better. I hope so. It is a little crooked. We got something going on with our clamp here. We're just gonna bump this with a hammer. I don't really like what's going on, but here we are learning. No, it's not happy. All right. All right, so what was going on was there's a set screw on the handle that was loose. I still am not overly confident that this is going to bend this, but we have to try it. We must try it. It's just unclamping. have really high hopes for that. All right, so next, I did try a test piece, and the vendor just won't do it. Its capacity says 16 gauge, and apparently it is close to that. Maybe a narrower piece would not be so bad, but being 12 inches wide, I think that's what's causing some of it. Or maybe I just don't know what I'm doing. There's always that. So, what we're going to do is actually make some score marks with just a air die grinder cutoff wheel to relieve some of the pressure, and we can stitch weld it back up if we're really concerned about it, but I really think that it'll be fine for what it's going to be doing. So we'll get set up for that next. All right, so we've got our air grinder. I like these a lot. This is made by Clutch. I think I got it on Northern Tool or something. And these cutoff discs are very thin. So one other thing I'm going to do is try to lay out where I want to cut. How long of a cut I want to make, rather. So we'll come in an inch. This is what, 12, right? That's 12, so set this at 10. We'll come in an inch, and we'll go 1, 2, 3, 4 inches. It's not working as well as I wanted. Come in an inch. Go 1, 2, 3, 4. All right. I'm going to cut to the I think inside of the line, right on the line. I don't know. I do know we're going to put a clamp down on it. Let's learn together. I'm thinking maybe right on the line. Let's do right in the middle of the line. All right, we'll flip it around and cut the other side and change the battery. Or clamp. Absolutely love this cable. And cover ears. All right, I honestly think now that I did those relief cuts, even though the capacity is still more than this is rated for, that it will bend it. And let's find out together. Before I cut the other one, I might as well try this one. Please bend. Better. Still a lot harder than I thought it should be. Pretty good. Actually overbent a little. Let's fix that. There it is. First 90-degree bend. Let's do another one. I bet you if I took that line further, it would even do better. So unfortunately, I think I'm gonna have to hold the lock on. Let's put you over here. Too far. All right, that's pretty good. Look at that, huh? Got three-dimensional real quick. Now, the real question is, did it stay the width that I thought it should stay, which is 10 inches. Spot on. Look at you. Man, how nice is that? I need one of these that does thicker metal, because that's just plain awesome. So really, I could weld these up if I wanted to, but I don't even think I'm gonna have to. Wait till you guys see what this thing makes. All right, that was brilliant. Let's get you guys moved back over here again. Not that you can probably see too much of what's going on, but we're going to work on that. This is new. So let's do the same thing. Let's do an inch. This is going to be easier because it's less of a bend. So let's come in an inch here. And we're going to cut that all the way up. An inch and an inch. Eyes, ears. I got all my dollars out of that one. All right. Move you guys back. Interesting. We're going to have to come over to the side on this one. she's definitely bending easier, but it don't want much more than that for thickness. I'm very surprised. I'm also curious about some things. Well, here we go again. This is going to be a good example of why they call it a finger break. So I can't get over here far enough. Pause. Fix. That's better. Okay, so I can't get over this way far enough. So what we're actually going to do is remove somewhere these Allen wrenches. Right here. We're going to remove one of these fingers. Not my fingers. Hopefully. One of these fingers. Just like that. That finger comes off of there. Very cool. So now I should be able to, and I very much can. I can get to position now. All right, we're on the bend line. Time to bend. Well, I keep going beyond by a little bit. Guess it's just a learning curve. So now, drum roll, please. Put our finger back out of the way here. This motor plate should fit inside of the base plate. And it does. It's a little tight. That's fine. We can fix tight. How exciting. I think, so this should measure, all right, it's size on size. So we're going to use some blacksmithing here. And set this off to the side. Sharpen the bend, if you will. So I think if we do that and maybe open this up a little bit, which, go back to our finger break real quick. And just try to tweak that a little bit. Too much. That might have been too much. Look out. I thought it was going to fit better. Now let's get some 3/8 bolts and test out our hinge point. Look at that. 3/8 bolts just laying around. That kind of fit. This is obviously temporary. It's not the right bolt. Well, I'll be darned. This actually needs bent in a little bit. That looks pretty darn good. We can tweak it as we need to. It looks like the hole here lines up with the slot pretty good. Might need dressed a little bit. Keeping in mind, I drew this on Fusion 360 off of a picture, so, and I had never used the sheet metal side of Fusion. Pretty happy. Let's tighten this bend up a little bit. That's pretty good. Oh yeah. Time to wash up real quick. All right, welcome back to the plasma table. I had to use that other piece I made for something else, so we have to burn another one out. No big deal. First thing we're going to do is fill our water table up. Once again, big thanks to Westweld, who sent me a bunch of pictures and links to where he bought all his stuff for his setup he made on his Langmuir Crossfire table. And it's been working really good. The drain back is a little bit slow sometimes, and I just poke my air gun in there, help it out a little bit. It's been great. So maybe I'm doing something wrong, but it's been good. So let's fill up the table with some fluids. So we'll turn this valve on and this valve off. Turn our pump on. Start filling. The mason jar is just there because it thought it hit the ceiling. That's it. She's full. How simple is that? Alright, I think we can get another 6.5-inch circle out of this piece of scrap. As a matter of fact, I know we can. So let's do that. Bigger than 6.5, but we can kind of use this as a gauge. Squeeze every little bit of material out. Open up our fire control. First thing we're going to do is home the machine out. It tells you it's going to move. Move away. Then we're going to jog over. So about where we think the center of that is. Alright, get this out of the way. We're going to zero all work axis. We're going to put our flash stick in here so we can load our program. And that one was basket plate. Just a basic 6.5-inch circle. Set origin point to the middle. We're going to turn dry run on. Start. It sure looks like it's going to clear. Let's move you a little bit here. All right, let's try and do the real cut. Air's on, machine's on. I think everything's good, so we'll turn dry run off and hit go. I always like to home the machine before I shut it off. I actually then come off of the limit switches. I don't like sitting on the limit switches. So we can close that. Shut off our table, shut off our plasma cutter. Shut our power strip off and drain the table. Let's see what we did. Nice 6.5 inch circle. Just like that. I absolutely love this table for what I'm doing with it. Come over. Now we're over here at the 2x72 belt grinder. This is actually one I built. Very good machine. All deburred, ready for the next step. All right. As a machinist of lots of years, I'm not super proud of what I'm going to do. But because of what it is, and the fact that it's a whopping 15 RPMs, we're just gonna do some eye calipering. It's gonna be fine. Let's get our mark in the center. And then we're gonna do the old eye caliper. I think we'll drill one hole, get that bolt put in, tighten it up, and then drill the other ones. Alright, as most of my projects go, let's get fairly unnecessary and complicated. I have small bolts, I don't have nuts that go with them, so we're going to drill and tap this plate with a massive 832, which is not massive, but hey, let's try not to break a tap. First we need to center punch the hole with something that I'm pretty sure isn't a center punch, but it's the first thing I found. Will it do center punch those? Alright, we need a real center punch. What are we doing? Hey look, a real center punch. Now, if I could just find the fake center punch hole. Oh yeah. It's so weird that it works. A little bit of oil. It's a number 29 twist drill. If you're looking to drill and tap an 832 hole. Quite certain there's barely any threads in there, but if you do it 4 times, there's barely any threads times 4. Ooh, I get to try out my new vise. There we go. We just have a vise all of a sudden. How cool is that? Just going to switch back to this drill right now because I have a feeling that I would grab that and drill the wrong size hole. Ask me how I know. Hey, that fits so much better when you grab the right bolt. So, give it the old eyeball there. Does this fit in there and do stuff? I don't think. Oh, you know what we'll do? We'll switch back to the big drill bit that I didn't want to use. Just to get a center mark on the lower plate. Switch back to the big drill, or the tap drill. Perfectly oversized hole. Grab a bolt, grab a wrench, back to the clearance drill. Close bolt bin before I dump it all over the ground. Ask me how I know. Then we'll put our motor plate back up here. I think I'm going to need an extra long Allen wrench to reach in here. Matter of fact, I know I do. Let's go try and find one real quick. Alright, exciting news. This Icon 1/4-inch drive set, I've never used it. I've always been excited to use it, but I just never have. Look how neat. Extension. Little driver. In theory, that 2 set screws in here. Should be able to, oh yeah, that's going to be fine. Look at that. That tool worked out perfect. Let's fire this thing up. Extra sketchy wiring here. It's not covered up yet. It's fine. You'll know when you touch the back. Power on. Look at her go. Tilt. How awesome. Alright, I'll show you the next thing that we have to figure out. Stay tuned. Alright, so we're moving on to this plate, which I burn out on the plasma already. We got to take our motor plate back off. And I need to drill, so we'll center punch those. Just do a light tap to see if I need to move it any, and then send it home. Alright, let's knock these screw heads down here real quick. Reattach our motor plate. Good enough. So, the theory behind this is this basket will go on here. Probably line up with 4 holes close enough. Looks like it's going to. And then that plate will retain it. So let's get some hardware. I mean, for a plasma cut part that I drew on Fusion 360 off a picture off the internet, I'm really not mad. Alright, here's the concept. Basket goes in sandblaster. Nozzle is pointing down. Put parts into basket. Alright, so that's going to wrap this video up. So that's how you can take some images from the internet and a little bit of hard work and a little bit of learning and thinking and Fusion, and you can save yourself $1,000 and create your own tools. So I want to thank everyone for watching, and we'll catch you on the next one.